combination of circuits and its simulation waveforms. So in the last class we have seen how the bridge rectifier works and how the diode works. So we do the combination of these component circuit, and then we will see the waveforms. So we have generated plus 40 volt here amplitude with the 50 hertz of frequency, and here the minus 40 volts and then 50 hertz frequency. So we will add a diode in front of it just to cross check the output. So to this diode we will connect plus 40 volts here, we will connect minus 40 volt AC, and we will merge these two so we can get only positive half cycles at the output side. So here we need to filter the things here. So we have to filter these, and with this, these are the non-required waveforms. So the delay here, the delay is from 0 to peak 40, and then peak 40 to again it will come back to 0. So we have to reduce it. We have to reduce it to somewhere around 20 to 40, and then we'll gradually decrease it to 20 again, and then 20 to 40, and then gradually decrease. So the below part here, so this part is unwanted waveform when you compare it to the DC signal. So now the delay has been reduced. If you can see the delay here, and you can see the delay here, the processing delay is too less as compared to the previous one. So we have to connect the filter here. So we use the capacitor as a filter, and we will make it ground. So how to calculate the capacitance? We will see the formula. So we can go for C. Capacitance is equals to 1 divided by so you can go for 2 pi, and frequency as well as input voltage. So here in this case the frequency is 50 hertz we have taken. So you can take 50 hertz as a frequency, and the V in here is 40 volts, so it will use the 40 volts, and the total answer will be around like 79 or 80 microfarad. So we'll take 79 microfarad or 80 microfarad round figure, so that capacitance value we will connect it parallelly to this particular circuit. So when we connect the capacitor, and then we will see the waveform. Connect the capacitor here, and the other terminal we will connect it to the ground. Click on the ground, so you can place it somewhere here, and this connected to C. So double click here. I'm going to put 80 microfarad with working voltage of 40 volt. Click OK, and here the waveforms. To see the waveform we will go to the oscilloscope. So please add the oscilloscope. Connect input here, connect output to C channels. I'll connect the output C channel here. So we will see the output when we do the combination of entire circuit. So I'll remove this. We will connect the voltage regulator. So our next target is 40 volt to 5 volt DC. So 40 volt to 5 volt DC, we are going to use the regulator option. So we will connect the regulator here. So we get the input voltage and then the output voltage, and then one pin is connected to ground. So we'll do this combination. Go to the component mode, go to the part list. Here you find out if I need a 5 volts, I'll go for 7805, and I'll go for 10 milliamps. It's a low current. This one here, and I'll connect here. This one is to connect to ground. Output side we need one more capacitor for just filtering purpose, or to block the DC, to block the noise. We'll give one microfarad here with the 5 volts. We'll see the waveforms. Connect the oscilloscope here. A channel I'll connect it to the input side, B channel I'll connect it to the inverted input, and C channel I will connect it to the output of C1, and the D channel I will connect it to output of the C2 or 7805, and then we will run. Now you can see this waveform, the unwanted waveform. So this is from the positive side, and the signal has been reduced, and you can only see the spikes here. So this is how we are going to filter the AC signal or the waveforms, which is varying from 0 to 40, and here it is 0 to 40, it is going to peak, and 42 again it will come back to 0. So we have reduced it, and somewhere here at this point it is going to peak to 40 volts, and then it will come back to again the same voltage, again it will go back to peak 40, and again it will come back. So these are all called as spikes here. So this is almost like not varying completely, so delay has been reduced as small as possible.